Okay, let's continue with the isomer identification. So in this exercise, we are going to identify whether they are isomers or no. If yes, then we'll be fine. If no, we have to state the reason. So in general, still remember just now we say the definition is same molecular formula but different structural formula. So in general, when we look at these two structures, we will notice they are different because of the CH3 here, means that they have the branch. So that means fulfill the first requirement, different structural formula. Then next we will check the molecular formula. Based on here, we have 4 carbon, and then hydrogen 3, 2, 5. 3 plus 2, 5, 5 plus 2, 7, 7 plus 3, 10, H10. Another one, because there is 2 here, means that there are 2 carbon, plus 3 and 4, so 4 carbon. So 3 times 2, 6 over here, plus 1, 7, 7 plus 3, 10, so H10. So both of these have same molecular formula and different structural formula. So the first pair is isomer. Now let's check the second one. So when we look at again the structure, also look very clear that they are different, because here the O is bonded to H, but another the O is bonded to the carbon. So that means again they have different structure. Okay, next we determine the number of carbon. Based on here we have 2 carbon. Hydrogen 3 plus 2 plus 1, so 6, and then 1 oxygen. Here also very obvious, C2H6O. So both these also considered as isomers. Let's look at the third pair. So again, we also see here is COOH, here is COO. So means that they have different structure. Okay, then as usual, we calculate the number of carbon, 3 carbon, and then 3 hydrogen plus 2, 5 plus 1, 6, and that is 2 oxygen. So the other one, 1, 2, 3, 3 carbon, so 3 plus 3, 6 hydrogen and 2 oxygen. So the third pair also are isomers. Okay, the fourth pair, when we look at here, they are OH, but this one have no OH. So again, we can see they have different structure. Next, we will check the number of atoms. So for the first one, we have 2 carbon, 3 plus 2, 5, 5 plus 1, 6, and then 1 oxygen. For the other one, we have 3 carbon, and then we have 3 plus 2, 5, plus 3, Ha. Even though they have different structure, but they also at the same time have different molecular formula. So for the fourth pair, they are not isomers. Okay, let's check the last one. Is the again very obvious when we see one is contain Cl, another one is bromine, so they have different structure. So again, when we write the chemical formula, C2H5Cl, another one also C2H5 but is Br. So for these two, they have different molecular formula. So they are not isomers. Okay, so now I would like to check another one. Let's say if I have CH2Cl and then another one is CH3. Now let's compare these two. Okay, so this one also C2H5Cl. So when we look at this chemical formula and this chemical formula, they have same molecular formula. But at the same time, the Cl is bonded at the terminal carbon. So basically, they also have same structural formula. So if I compare these two, they also consider non-isomer because they are similar. They are same. Okay, with this few examples, hopefully you can identify whether they are isomers or no.